Hello, everyone. We're going to go over section 8.2. 8.2 is a graphing, a very visual section, but since we're not together and we're not going to work these out as much on paper and pencil, I'm not going to really have you graph them as much as I want you to be able to describe and recognize changes in graphs. So when you finish watching this video, you're going to do a short Google form to show your understanding of these graphs and how they work. If you have a calculator, you can use it, but I'm going to show you how you can do a lot of these without ever looking at your calculator. So 8.2 is called reciprocal function family. And what 8.2 is looking at is what do graphs look like if it's a number divided by x? So if we look at something called a reciprocal function, it's looking at a graph that is any number. It could be 5 over x, 3 over x. And the basic one, we call it the parent one, would just be like 1 over x. There's a name for these groups of functions. They're called hyperbolas. It's one of my favorite words to say in mathematics. And hyperbolas are interesting because they're one of the few graphs that we draw that are disconnected. Instead of being made up of one continuous graph, they're actually made up of two parts. And those two parts are called branches. So when you draw a hyperbola, you see two branches drawn. So this is what your basic hyperbola looks like. Your hyperbola looks like this. If your number on top is positive, so if it's 5 over x, 3 over x, you're going to get a branch in the first quadrant, and it kind of has this like sloping effect. And then you're going to get a branch diagonal from it in the third quadrant. If the a value, if the numerator or the fraction is negative, you can put the negative out front or on top. So like negative 5 over x or negative 3 over x. What it does is it flips it. And we've had conversations about making something negative and that flipping. So now instead of having branches that are in the first and third quadrant, now we flip it over and we have branches that are in the second and the fourth quadrant. Another thing that's important to know about these hyperbola graphs is they have two asymptotes. Asymptotes, we talked about them a little bit before with exponential functions. An asymptote is a line that a graph gets really close to but never touches. It kind of serves as a guide to how we draw graphs. So with these, we actually have two asymptotes. We have one vertical one, and your basic one has a vertical one going right along the y-axis. And then it also has a horizontal one going along the x-axis. So it kind of creates like a cross effect. So you'll have this vertical axis, the vertical asymptote along the axis, and then a horizontal asymptote. And what that does is it kind of helps you draw those branches, because as we draw the branches, it gets really close to the axes, but never actually touches it. So those are just some basic terminologies that I'm going to ask about. So your general form, and this is going to go back to things that we've actually talked about all year. We can take this basic parabola with the two branches and we can shift them. We can shift them right or left. We can shift them up or down. To decide if we shift it right or left, it's going to depend on the denominator, whatever is with the x in the denominator. If it's an x minus, so like x minus 2, x minus 3, it's going to shift to the right that many spaces. If it's an x plus a number, x plus 5, x plus 6, it's going to shift to the left. So subtracting from the x is going right, adding is going left. You may want to take a picture of the screen just to help you with that so you don't have to refer back to this video. The number after the fraction, so after you have the a over the x plus or minus h, any number that you have at the end is going to shift it vertically, up or down. So if we add a number on the end, like a plus 5 at the end, that's going to move it up that many spaces. If we subtract, it's going to move it down. We call these horizontal shifts and vertical shifts. So if we move horizontally, what it's going to do is it's actually going to move that vertical asymptote with it and change the domain. If it moves vertically, it's going to move the horizontal asymptote up or down and change the range. So the biggest thing that you're going to be asked to do, other than just a description on your Google form, is you're going to be asked to describe or understand descriptions of these transformations. So here's some that we have done, very similar ones together, where it will ask you, what are the changes? What are the switches? It can have anywhere from 1, 2, or 3 things that happen with it. With this one, it's going to the right 3 because of the minus 3 here, and it's going up 9. It doesn't flip because there's no negative. This one does flip, or we could say it reflects because of the negative in front, and then it also goes down 6. It doesn't have a horizontal shift at all. And then this one goes left 1 because of the plus 1, and then down 9. This one does not flip. So those are just very descriptive, and I'm going to do a lot of things like that on Google Form rather than have you draw things. When you write out your asymptotes, when you write something that's a horizontal asymptote or running like this, you're always going to write them as y equals. Your vertical asymptotes are always x equals because they're like vertical lines. So with something like this, and again, I'm not going to make you draw, but at least gives you an idea of some of the shifting. When you see something like this, the first thing you're going to write down or look at is what is the transformation. So this is going 4 to the right and 1 up. So what you do with this is you go over 4 to the right, and that's actually where your vertical asymptote is going to go. So that tells you where to draw that. We usually draw it as a dotted line. And then the up 1 is going to show you where we draw the horizontal asymptote. Then you can put your branches in. The number in the numerator here, this 3, really isn't going to change anything unless it's negative. That's going to flip it. So with this one, we're just going to draw it in the upper right corner and the lower left corner. And that is your hyperbola. And we can actually list, I'm not going to make you list a ton of things on your Google form, but your vertical asymptote, as I said, we went over 4 spaces, so it would be x equals 4. Your horizontal, it went up 1 place, so it would be y equals 1. When we talk about domain and range, your domain and range are going to be everything except where there's an asymptote. So your domain is all your x's except for x can't be 4 because that's where that asymptote is. And your range are all real numbers again, but y can't be 1 because that's where that asymptote is. Your vertical asymptote and your domain always go together because they're always talking about x's. Your horizontal and your range always go together. For this one, we're going left to 2 spaces. So you're going over 1, 2. We're going down 5 spaces. So down 1, 2, 3, 4, 5. And that's how you get that cross effect of those asymptotes. So left 2, down 5. Your vertical asymptote then, again, you went left 2, so it'll be x equals negative 2. And your horizontal asymptote will be y equals negative 5. So you cannot have a domain that includes negative 2 for your x, and you can't have a range that includes negative 5 for your y. At this point, I'm going to mention there is going to be another kind of special question at the end of the Google form, and the question is going to be about softball, my favorite sport, it's going to ask about the position I played. My favorite position, it is center field. Just put a note down like that so you get that question right. So here's a couple more, and then we are truly about done here with this one here. This one doesn't go left or right at all because there's nothing with the x, but it does go up 3. So when you draw your vertical asymptote, it's going to stay right on that y-axis, and then you go up 3. It flips. So since it flips, instead of having a branch in the upper right and the lower left, it just switches places. Again, horizontal asymptote, you went up 3. That's where it's there. Vertical asymptote, you didn't go right or left, so it's y equals 0. And then finally, this one does flip as well because of the negative. It also goes to the left 1, and it goes down 5. So left 1, down 5 creates that cross effect. And then we draw our 2 branches, and our branches, again, have flipped. So that's why you see it in the lower right and the upper left. These were some kind of working backwards where I was asking you to write the equation. You weren't drawing anything. So if we start, this is called the parent function. If we wanted to go left 3, we're going to add 3 to the x value. If we wanted to go up 2, we're going to add 2 at the end. This one wanted to go 5 down, so all we do is put a minus 5 at the end. We don't change the denominator at all. This one wanted to go 7 right, so we're going to do a minus 7. And then if you want to flip it or reflect it, you can put the minus sign in the very front, or you can put it with the numerator. Totally up to you. And then this last one goes right 6, so we have a minus 6 in the bottom with the x minus 6, and then 3 down is a minus 3. So that's section 8.2, all talking about hyperbolas that are made up of these 2 branches. The biggest thing I'm going to ask a lot about in your Google form are the shifts. So as long as you know how to shift right, left, up, or down, and you know the parts of the graph, it should not take you very long to go through and do that form. That is the end of 8.2. Good luck on the form. Let me know if you have any questions.